The purpose of this video is to show how to control a Mitsubishi A800 VFD over Ethernet using an A8 NEIP-2P communications card with a Rockwell Automation Control Logix controller. I'm going to start out at the very beginning in case you don't already have one in your plant. You're going to have to, the first thing you're going to need is you're going to need the EDS file for the communication module. To do that, you have to go to Mitsubishi Electric, their support site, and it's us.mitsubishielectric.com, and then it's /FA/EN. And you are going to need an account on that site as well. I'm already logged in, so I'm ready to go and start searching. So to get the EDS file, I'm going to search for A8 NEIP underscore 2p.eds. Go. And it's going to search for a bit, and poof, it came up with one of the things that we need. So I'm going to click this link. It's volunteering to download it to my computer and save it somewhere. I'll just put it in the downloads folder here. And now I have the EDS file. Okay, it comes in a zip format, so I'm going to navigate to the folder, and I might copy this to some place that's a little easier for me to find. So I'm going to put it over here in my downloads folder on D drive here. And I'm just going to paste it in here, and I will extract it. Okay, I'm going to navigate to the folder it extracted it to, and there's the EDS file, and I can see it wasn't changed since 2013. And just as a note, I'm pausing this video frequently to cut out as much unnecessary stuff as I can. So now I'm going to start the programming software. I'm going to have Logix Studio 5000 version 31. I've already got a copy of it going here. I'm just going to switch over to it. And here is my program that I'm going to want to control the drive with. So once here, I'm going to go to the EDS wizard. That is found under Tools, EDS Hardware Installation Tool. Once you get there, this window will pop up. Next, I'm going to register an EDS file. I'm going to browse to it. So I browse to the folder it was in. It was right here. I'm going to select it. I'm going to choose Open. Choose Next. It's asking me if I want to install it, and the green check mark means that it's a valid EDS file. Choose Next. It's going to assign it an icon, and it's going to call it an AC drive device. That's kind of something you're going to need to know in the future. Choose Next. It says you'd like to register the following device. Yes. Poof, successfully completed the EDS wizard. The next thing that needs to happen is you need to figure out where you're going to put it. I have an Ethernet card already in my project, and I have a number of these drives already in here, so I'm just going to add one to the same Ethernet module. So I have an Ethernet module in my Control Logix chassis. Underneath it, I see this Ethernet network, and then I'm going to assign it to this. You're going to need to know the IP addresses on this network, and I do, so this is where I'm going to put it. So to get it there, I'm going to right click on the Ethernet network. I'm going to choose New Module, and I'm going to come up with a big long list, a very intimidating list of everything you can imagine. And to get there, the first thing you want to do is click Clear Filters. Oops. Clear the filters like that. And remember the AC drive device? So I'm going to put a check mark in that, and that will filter it for only that. And that's the only device that has assigned itself that class, AC drive device. So this is what we're going to choose. So I'm going to pick the HMS A8N. That's the Ethernet card we just talked about. I'm going to choose Create. This is the dialog box that pops up. I'm going to give it a name. We'll just call it Test A800. I'm going to assign it an IP address of 192.168.1.125. And this is the important part right here. You're going to click Change. Once you get here, there's an incredible range of options for controlling this. we're going to choose exclusive owner. We find that works best for us. So I'm going to choose exclusive owner here. Choose OK. Hold on, don't choose OK. Gotta go back in there. Choose exclusive owner. Now, there are a huge combination of control schemes, as we saw from that list, and it gets even worse when you have to set up the drive to match them. So what we're going to do is we're going to choose instance 2171 exclusive owner in the drive, and then I'm going to want certain data back from the drive, and I'm going to have to set up these connection sizes to match what I ask for back. By default, this instance 2171 that I just mentioned in the drive gives us 2 words back from the input. It gives us the status and the speed feedback, and it wants 2 words of output. It wants a command, the command bits, and the speed command. And when I'm saying words, I'm talking about words in the drive, and those are integers. So by default, you would change this to integer, and there would be 2 integers coming back, and there would be 2 integers going out. Change those to those. Hit OK here. I'm not going to hit OK, actually. Now, in our case, we've decided that we want more than just the speed feedback and the drive status coming back from the drive. We would also like to get the terminal status and the current. That extra information is going to raise our input size from 2 to 4. So I'm going to increase this to 4. Hit OK now. It's asking if I want to change the module definition. I did. So in conclusion, or to summarize, I changed it to exclusive owner, input 4, output 2, integers. I'm going to choose yes. Now you get back to this original dialog box, and when I click OK, it will be created and the appropriate tags for controlling it will be created. So I'm going to close this dialog box, and you can see over here that the test A800 drive got created. If I scroll up to the controller tags, I will find that the tags for that drive automatically got created, and here they are. Now, by default, since the Rockwell software doesn't know what the structure of these words is, what's inside of them, these tags by themselves are not terribly helpful. So what Porter Engineering has done is they've created user-defined data types that are set up to already talk to these drives, and they include all the appropriate bits in there. So I will show you how that works. If we look at some of the ones I've already done, we'll come over here to this one. I'm going to scroll down to the end, and we'll look at this one. So this is how I control one of the other A800 drives with this. I'm going to just copy and paste these rungs. I've done some additional programming here. So this actually will check out the health of the module as we're running. So if something happens to it, it falls off of Ethernet, we'll know. I've built a user-defined type that includes this entry status. But if I come in here and I type in this test A800 right here, that's the module. That's the new VFD name, and I'm going to get the entry status of it, and I'll create. I'll do this offline. I'll pause the video while I create these things. Actually, I'll just show you how this procedure works. So I've created a new tag, and I've got a custom defined type called Ethernet drive status. And so I changed this name down here from what it was before to test A800 entry status. I'm going to create a new tag, and the custom type I made was called Ethernet drive status. I'm going to choose that, and now that tag has got a member called entry status, and I'm going to move that over to here. And the way this works is if the entry status for a particular device is 16,384, then it means everything is functioning properly. So I'm going to come over here. This is part of my custom type over here. I'm going to choose, it's going to be called test A800. And that was a bit that's also a part of that same custom type that I had. And then here's just a bit that I will delete for the purposes of this video that is going to tell our HMI that it's there. Now, the important thing is, though, is this is one I've already got set up. So I'm going to remove all of this, the name of the drive from the previous one I have set up. I'm just going to put in this test A800, and you'll see that because it's the exact same type as all the other ones, this is going to be valid. See how it already found the rest of this? So test A800, length of 2, and down here I'll do the same thing. Replace this. It's going to be test underscore. I didn't name it enet like was my custom. Enter, and there's that. Now the interesting part are these custom defined types, user-defined data types that Porter Engineering built, and I'm going to show you what's inside one of those. So I'm going to choose monitor. I'm going to come in here. That's the one for the previous drive that we copied. And I'm going to come in here and I'm going to drill in here. And what they've done is inside this first byte that we're going to put out, that we're going to be sending to the drive, they've labeled all of the individual bits inside of it so that when you turn them on in the program, you'll know what you're turning on. And it's not just going to be some generic bit that you don't know what it is. They've done the same thing for the status coming back. You'll notice that I copy the data coming back from the drive into the status word, and it's got everything we need to know down here as part of its type. To show you how this works, I'm going to, I'll do a cross-reference on this. And you'll see that in the actual ladder logic, then they turn on that byte forward bit, or yeah, run forward bit. Back here, it gets copied into this data structure for the A800 drive, and that turns on the appropriate bit in the drive to make it run. That's about as far as I'm going to go. And a similar thing, the data coming back from the drive is in this input, and they copy it into the status, and they can use that in various places to see whatever. See if it's faulted. So like here, they see if it's faulted, and they act on that. So that's about as far as this video goes, and I hope it was helpful.